The measure of an arc is in degrees, while the arc length is a fraction of the circumference. Consider the arcs shown at the right. Since the circles are concentric, there is a dilation that maps C1 to C2. The same dilation maps the slice of the small circle to the slice of the large circle. Since corresponding lengths of similar figures are proportional, we can state R1 over R2 equals A1 over A2. Furthermore, R1 times A2 equals R2 times A1, simply an exercise in the cross products property. A1, in this case, will then equal R1 times A2 over R2. This means that the arc length A1 is equal to the radius R1 times some number. So, for a given central angle, the length of the arc it intercepts depends only on the radius. An arc of 60 degrees represents 60 over 360, or 1/6 of the circle. So its arc length is 1/6 of the circumference. This observation suggests the following theorem. Theorem 1010, arc length. The length of an arc of a circle is the product of the ratio, the measure of the arc over 360, and the circumference of the circle. Note the diagram. The length of arc AB equals the measure of arc AB divided by 360 times 2 pi r, the circumference of the circle. This equals the measure of arc AB divided by 360 times pi times the diameter. Problem 4, finding arc length. What is the length of each arc shown in red? Leave your answer in terms of pi. A, given this diagram, the length of arc XY. Well, that will equal the measure of arc XY divided by 360 times pi times the diameter. That's our formula for arc length. In this case, that's 90 divided by 360 times pi times 16, or 4 pi inches. Part B. Here we're asked to find the length of arc XPY. So we'll set up the measure of arc XPY divided by 360 times 2 pi r. This is 240 divided by 360 times 2 pi times 15, or 20 pi centimeters. Your turn. What is the length of a semicircle with radius 1.3 meters? Leave your answer in terms of pi.